Okay, Roger. My name's Jeff, by the way. W4 United Echo Bravo, WHENM. I'll have to check that out, the antenna compendium. I guess that's the ARRL. See if I can find the article. Maybe search for it on the internet. But, well, usually the lower the resistance and the resistive losses in the antenna, the better the efficiency. Of course, the antenna doesn't have to be resonant. You just have to be able to get current to flow in it. But like Dave was saying, typically as the resistive losses go down, the bandwidth goes down too, because it becomes purely reactive on either side of resonance. By the way, I just measured the inverted L, Dave. It's 2-to-1 Viswar points are it's 48 kilohertz. Go ahead.
Okay, well that's just about what I see online. Okay, yeah, just about. I see fine. I see 40 kilohertz. Reactive starts to get so it starts to monitor more than anything.
Yeah, well, 2-to-1's getting pretty severe anyway, but yeah, so it's about 48 kilohertz. So I just motor tuned the thing. Now, putting the cage on it will help broaden it for sure, but I don't know if you get the full benefit if the radials are still small. I have to think about that. Depends on how many radials you have and if you have gang tuned them. But I mean, the problem with elevated resonant radials is that the bandwidth of those systems is always going to be less than like 120 radials on the ground, or basically a copper plate, because there's no resonance involved in the counterpoise. So the only reactance you have shifting is on the fed wire. But with the elevated resonant radials, they're moving along with the radiator. So it's kind of like a dipole, where both halves are moving, or like this J-pole. It's fairly narrow bandwidth, but at the higher frequencies, percentage bandwidth is fairly narrow. But the J-pole bandwidth is pretty narrow because it's a half wavelength, and then there's that quarter wavelength section that's also moving reactance with frequency as well, right?